podcast with Michael Roper here, and this is episode number 506. So welcome to the Smart Buildings Academy podcast. Today's episode will be about why smart facilities aren't always smart. Now, we titled it this because you can have the most state-of-the-art user interface, you can have the coolest graphics on the market, and maybe even have some field controllers or end devices that have IP capability. However, if your internal team does not know how to use these components of the building automation system, then it's kind of worthless because all those features just sit on the shelf and they're never used to their full potential. So we're going to talk about today how we can bridge that knowledge gap with your internal teams and how to make your building automation system run the way it was designed and get the most efficiency and productivity out of your building automation system. Okay? So all information that I'm covering in this podcast, if you want to watch this or listen to it again or maybe forward it to somebody else, can be found on our website at podcast.smartbuildingsacademy.com/506. Okay. Since we got our introduction out of the way, we'll go ahead and jump into our first topic of the podcast. And I want to talk about what is a smart facility. Okay, so let's define that first. So smart systems combine multiple subsystems into one unifying system. And we define this as a building automation system, a true system. So these can have subsystems such as HVAC, which is our most common one we have, usually is what we work on, is heating, ventilation, and air conditioning systems. Also, lighting controls might be the second one that we see a lot. You'll see a lot of those on energy type projects when they want to save energy. And then we also have access and security systems. Maybe it's a fire alarm system too as well, and also an energy monitoring system. So we got a lot of different building systems that are out there. And when we combine those all in one, that's going to be considered a smart facility. Now, these smart facilities, they use automation through sensors and software. So we're going to be using logic and feedback loops to maintain building conditions. So we're going to be monitoring HVAC conditions. We're going to schedule lighting and turn things off when it's unoccupied to save money. Security and access control. We're monitoring the safety of who goes in and out of the building. And then fire safety as well. That's a safety type system. And then energy monitoring, which is a very important piece today as we see a lot of commercial office buildings. In any commercial building, our goal is to save energy. Okay. So these are designed to reduce human error and also improve consistency. So one piece of technology that's included in smart facilities is AI. You might have heard this coming upon the horizon. It's becoming a big deal. AI can do a lot of different things. It can do analysis to see how we can get more energy efficiency out of the system. It can do predictive maintenance. It can maybe predict an issue before it becomes a failure. And then we can also do fault detection diagnostics to get a better diagnostic condition of the system. A lot of these things are built in modern user interfaces, or they can be added on to the user interface too as well. Okay. Now, we talked about smart in the introduction. Smart doesn't mean self-aware. We still need humans to set these things up. Okay. If they're not properly set up and monitored by humans, then they're not really smart because they still rely on us for now for human intervention, I guess you could say, to make the system work the way it should. All right. A BAS with no one monitoring it becomes passive and it's not smart. So if you're not keeping up with building conditions, maybe you had an addition or a remodel, or you maybe you relocated some sensors, or you did a retrofit. So if these aren't updated, it's just going to be a passive system and it's not really smart anymore. You're not saving money. You're not increasing comfort control and things like that. Now, another thing, a tech must be supported by operational goals too, just not looking good on paper. So these things are designed to support whatever operational goals that the company might have. Maybe it's designed for energy efficiency. The company's goal is to save or reduce a percentage of energy consumption per year. It could also be a city or state code to do that as well, or they get fined for it. We're seeing that stuff too as well in some cities and states. It could be for comfort control. We're trying to increase comfort control and keep the employees working and increase their productivity so they don't get sick and go home and not want to come to work. Okay, so comfort's a big deal too. And there could be some sustainability goals. Maybe your building has a goal to be LEED certified, or kind of maybe a green building or something like that. So these are all examples of what it could consist of a smart facility. Okay. Now we talked about why they're not always smart, and this is the illusion of intelligence. Okay, so people believe automation fixes everything. Okay, so you might have a standalone building, a pneumatic system, and we want to put a BAS electronic system in there, and we think that's just going to fix everything right out of the gate, just because we invested the money to do that. Now that's going to fix a lot of things for sure, but don't make sure we understand the full capability of the system. Make sure we understand what the software can do, because if you don't do that, you're not getting the full capability, and it can lead to complacency. Okay, so touchscreens are good with nice graphics, but they don't always mean the system is optimized. That's what I was talking about in the introduction. You can have 3D graphics, or you can have a touchscreen display on a controller, but just because things look nice doesn't mean they're functioning the way they should. Okay, so don't be deceived, by a nice graphics interface, because that doesn't mean it has optimum functionality. Also, faulty logic or default settings are often never corrected. So, there could be during startup and checkout, maybe there was something that was never corrected in the software. Okay. Maybe you had a low limit that wasn't tested during startup and checkout, and then that, you never knew if that's going to protect your coil or not. Things like that. Okay. Default settings too as well. A lot of these user interfaces and startup software comes with default settings. So if those are never corrected, and usually you want to make sure these are backed up by whatever's in the plans and specifications. We want to make sure that we put whatever these settings are, like, unoccupied set points, occupied set points, time of day schedules. Make sure that they're not just on the default. Make sure they're customized and set up the way the job was designed to be. Okay. Also, systems left on permanent overrides can give a false sense of control too. And usually, sometimes technicians will put them in override just to test things, or they might just be putting it in override to make the problem go away temporarily, and they forget about it. Okay. So when you do that, you're locking out all of your capability that you paid for and you invested in your building automation system, and you're just overriding the system to do the minimal control just to get by. Kind of like putting a Band-Aid on it. Okay. Same thing goes like with set it and forget it. It only works when the system is properly set up. And so just because you set the maybe a set point during startup doesn't mean that's going to work 2 or 5 years down the road. Okay. You could have different tenants in your building that have different hours of operation. Okay. That's one example that I can think of off the top of my head. Maybe there's a remodel. You might have different criteria for that. So real intelligence is validated through ongoing monitoring and feedback. We got to keep up with the system. All right. Keep up with it. Making sure we understand what our spaces are serving, and what intelligence they need for that. Okay, so we talked about some solutions, and these will be like key knowledge gaps, and we'll identify some of these in this next topic here. So a technician, one of them is they lack networking experience, and that's one thing that I see a lot when I teach students, and even when I first came to work at SBA, I wasn't really good on networking either, because when I was in the field, I started out in 2002, and I think I left around 2012 or so. And IP was really not a big thing back then. We would just put it on the supervisor, give it an IP address. If there was a web server, we'd put that on the web server, and then we're done. Today, there's IPs for everything. Okay, there's IPs for relays. I've seen some relays on the market that you can put on the network, zone sensors, low limit sensors, everything. So everything's going to IP. So understanding the theory of subnetting, or if it's on a backnet system, BBMDs, the backnet broadcast management device tables, and the backnet device table. Understand how to set that stuff up. Now, engineers design specs without sometimes seeing how it works in the field. So just make sure that, we double check to make sure that it wasn't kind of like just a copy and paste sequence or copy and paste plan and spec. And we need to make sure that this is going to actually work out in the field. And they might be unfamiliar with certain controls implementations, especially new technologies like networking. A lot of times operators too are poorly trained on BAS front ends, and that's just really due to not enough training hours during startup and checkout. Could also be due to high turnover within a company, constantly having to train new people how to use the user interface. So it's going to require a lot of onboarding training and things like that. So they receive minimal system training. Tribal knowledge is good. It's rarely documented or passed down. When I say tribal knowledge, that's knowledge within your team. That's cross-training people within your company. So you might have an expert on the user interface, and that person can also cross-train other people within your department. So sometimes that doesn't happen, but I'd recommend to encourage that internal training. Okay, we'll go to the next topic here, and we're going to talk about some real-world consequences of that knowledge gap. Okay, so one of them that we see quite often is alarm fatigue and disabled notifications. Or maybe you have critical alarms that aren't being acknowledged. So you go to the alarm log on a user interface, and I've seen this too when I do job walks, when I was, putting together proposals and estimating and things like that. The alarm log would be flooding the system. There's alarms everywhere that's maybe just notification alarms, sometimes critical alarms that have to be acknowledged before a system can run. A lot of these are being ignored, and that's called alarm fatigue. There's just so many alarms, we don't even know what to do with them anymore. So getting in there and cleaning those up is very important to maintaining your smart system. Another one, we have controllers left in override. We kind of talked about that already, persistent manual overrides. And that's something that can cost energy. Okay, so think about if we left a fan on continuously forever. We overrode it and it just keeps staying on forever. Or the chiller never shuts off. Okay, when the building becomes unoccupied or the outside air goes below a certain set point, say maybe 50 degrees or whatever, and the chiller's still running, even though we're bringing outside air in the building and economizing with our air handlers. So those are things like that. And, maybe that chiller was in override. That's going to cost a lot of money when it doesn't have to be. Okay. No one installs updates. This is a big deal too. It's not only an efficiency issue or productivity, it's a security issue. So firmware patches, if those come out from your vendor, don't ignore those, because sometimes they can have security fixes in that firmware to put that patch on your system, and it protects it from a cyber attack. Okay, so firmware is very important. So these missed updates can cause things like that and some security risk. Okay. Also, another thing that can contribute to inefficiencies is sequence of operation errors. Okay, maybe you have a system that's doing simultaneous heating and cooling at the same time. So it's fighting each other. Those two coils, the valves are opening and closing constantly, and they're just fighting each other within their own system. So that's one example that the sequence can be messed up, and it was unnoticed at the beginning of startup and checkout, because during startup and checkout, you're just going around the space, nobody's complaining about it, and it's just unnoticed. But behind the scenes, it's really, those two coils are really going against each other, and you're running your boiler all the time, you're running your chiller all the time. It's increasing more of a load on that system, and it's costing you a lot of money in energy, electricity, and also natural gas if you have a big gas boiler. Okay. So those are some things we need to check, is make sure our sequence is functioning the way they do. And the way they do it is make sure you get a functional test on your building system during startup and checkout. That functional test, and make sure you go through a functional testing agent too as well, because they'll ensure and give you a written documentation that the sequence is operating the way it should. All the devices on an air handler, for example, are working the way they should. The heating and cooling valves are not working simultaneously at the same time when it's just in cool mode or just when it's in heat mode. Okay. Equipment fails prematurely. This is a big deal too, from lack of proper scheduling or maintenance. Okay. So think about, and this can also tie into the sequence. Maybe there wasn't a rotation on the boiler or pump rotation. So you're just running those pumps all the time when you only really need one of those. Okay. So you're wasting energy there. And maybe you're running your chiller too much. Maybe you can shut that down every once in a while, or rotate a chiller or rotate a boiler. And instead you're just running them all the time. So we all know the more we run our equipment, it's kind of like a car, you're putting more mileage on it. Okay. So, and these things don't run forever. Usually, according to ASHRAE, they have a list of replacement recommendations for equipment and BAS systems. And it's around 10 to 15 years or so. I mean, I know we've seen some out there that are older than that, but if they're in good condition, and their top efficiencies are probably going to have to be replaced within 10 years or 15 years. If you don't do proper maintenance on those chillers, boilers, or air handlers, it can reduce it to half the time or significantly less. And that's a huge investment to replace that equipment because it's very expensive. Okay. And you don't know what's broken if you don't understand what right looks like. Okay. You might not know that your chillers are supposed to rotate. Okay. Only one can work at a time, and that's the way it was designed to do. But instead, for some reason, they're both running all the time. But if you didn't know that, if you didn't read through the original sequence that the design engineer laid out, you wouldn't know that. Okay. So that's important too, to understand and work with the design engineer or whoever designed your system. What's the proper way the system's supposed to work? Okay. Okay, so let's talk about bridging the gap with training. Okay, so we're going to go to this one here. And training is very important, as we all know. And it just takes time to do this. And sometimes it's frustrating when there's high turnover in a building. You're constantly training new people. I've seen that. It's really painful process to do that. So training HVAC techs on basic IT things. Okay. And then also you can train your IT staff on the mechanical systems. They might be wondering why we're even needing IP addresses for a relay. Okay. I'm still trying to figure that one out too. When I've seen that, but I guess I can see some advantages of that if maybe you don't want to invest in another unit controller and you just want to put a relay on the network. I can see that, or maybe it's a safety or something like that. So train the IT staff on the medical or mechanical systems. And then HVAC techs, we have to know about basic IT. We got to know about subnetting. We got to know about security. We got to know about, transport layer security. We got to know the difference between HTTP and HTTPS and how important that is. We need to know about the common port settings, okay, on that stuff too as well. Another one is role-specific BAS onboarding. So this is a good idea what you could do whenever you bring new people within your company. Provide hands-on labs where mistakes are safe and educational. Now, what that means is you can create like a sandbox simulation forum area. You can maybe create a site for them to play with that's not on your system. Okay, this is separate. It's not connected to any equipment, but maybe if you can have an area where you can have them, do some hands-on training on the user interface, hands-on training on a controller. If you have some space in your office, potentially, invest in some controllers and make a lab kit for them. Give them a supervisor controller, a field controller, and some end devices, and use that for your training in-house. Okay, train one person, like I said before, and have them pass down that knowledge and train new people. Okay, so the burden's not always on, the building engineer or the building manager's hands there. Okay, so do some internal training with that. So give the operators access to dummy BAS systems for practice. Now, I'm not saying they're dummies. I'm saying a dummy system that is not connected to any equipment is what I meant by that. Okay. Develop role-specific learning paths, not one size fits all. You might have someone that's, all they're going to do is, look at the user interface for any kind of alarms in the system. Okay, that's their job. So just train them to do that. You might have someone that needs to know how to troubleshoot field devices. Okay, so teach them how to use the service tool software and also how to do basic troubleshooting with a multimeter and how to determine if a sensor is bad. Okay, or something like that. So it could differ depending on your internal team's roles and their skill capabilities too as well. And don't assume everyone understands the system just because it's intuitive, just because they have all the bells and whistles and it's got a really nice graphical user interface, 3D graphics. Don't just think that they can automatically learn how to use that. A lot of times people might not admit that they can't do it, so you got to make sure they're comfortable asking questions. That's what I do a lot with my students when I teach my classes. I want to make sure that they're not afraid to ask, because there's never any dumb questions in building automation, because there's so many parts and pieces that we have to be experts on, it seems like. Okay. And treat training as a recurring necessity, not a one-time event. So it's not, and that's how it goes during startup and checkout. Usually it's just like, we get 4 to 8 hours of training and that's it. And that's from the vendor. There's no way you can cover everything in 4 to 8 hours. If you're working with a design engineer, make sure there's training maybe every 3 months for a year. Okay, maybe 2 hours of training, 4 times a year or whatever. And that should help you get some more training practice. Also gives you a chance to write down some questions next time they come to do their next training session as well. Okay, let's talk about communication. And communication is very important on this. So we want to let the operation teams review control submittals before installation. Now, submittals has everything on it. It's got your control drawings on it. Okay, it's got the cut sheets of all your sensors, devices, and controllers. Okay, you can see what all your controllers do. It's got the sequence of operation. We can see exactly what the sequence is doing. All right, so. And it gives you a chance to spot out some things before it goes out to bid. If you can catch this before it goes out to bid and before the installation, then maybe if they left something out, you can say, hey, I want to make sure we do night setback on that boiler, or I want a night setback on the chiller. Okay. Things like that are important to determine before the job goes out to bid, or maybe even before we can catch it before it gets installed. Or even better, maybe there's some features on there that you don't want, that you don't need, and you don't want to overpay for something you're not going to use. Okay. So that's communicating with the design engineer and communicating with the vendor, the controls vendor that's going to install the system. Those are 2 important features that you could do. Field personnel should feel safe reporting issues or concerns. Okay. A lot of times they might not want to report something, an issue or concern, because they might think they'll get in trouble for it, or they're, something like that. So just make sure you're in a safe environment. Communication lines are open. And this can also address an issue. They might have some questions for training. Okay. Encourage open conversations between other departments in your business, like for IT, your network department, your IT department. Also, if there's any engineers, like design engineers, like I talked about, and then also technicians, okay, in your internal team. So we really want to talk about everything, because when you get these conversations with everybody, you guys can learn from each other. You can learn about IT from the IT person, okay? You learn about why he doesn't want to give a dynamic address, a DHCP address over a static address, okay? Things like that. Eliminate the us versus them, okay, in your company, and be dynamic across all trades and departments, okay? So it's not like IT's on their own team and BAS and HVAC are against them. try to work together because you guys are on the same team, trying to make sure you're fulfilling some of your company goals. So make sure you're on the same team and it's not just like a battle or a competition between the two. Okay. Empowering technicians. This is a big deal too, especially, this helps your technicians grow. It also helps them stay in the company. It helps you retain these technicians. So let the technicians navigate the BAS front ends, okay, the user interface. Let them learn about it and explore it. Be safe with it. You might sit down with them, just show them, just kind of walk them around it. You might even get some vendor specific training in-house for that too as well. Provide read-only access. At minimum, training access is ideal. Okay, so you might not want to save things, just read-only, just a view only. That way they don't mess with the system if you're letting your technician work on a live BAS system on live equipment. Maybe just do read-only. Okay, no overriding capabilities, no adjusting set points at first. Just let them cruise the user interface, just kind of used to where everything's at, all the different choices and all that. Encourage technicians to propose new system improvements. This is good feedback from your internal team. Your technicians usually are going to be the eyes out in the field. They're going to be seeing things that might improve your productivity, your efficiency, and your customer satisfaction with your tenants in the building for comfort control. Maybe they're hearing a lot about complaints in certain areas of the space. That'll be something that you can focus on and improve it before it becomes a bigger problem or before they complain the higher ups in the company. Okay. Also offer pathways to specialize in controls, integration, or analytics. So that's just really with education. I mean, there's a lot of stuff on social media, YouTube, things like that, Twitter X, even at Smart Buildings Academy, we got a lot of courses that we could do that to help your technicians with career development pathways. Okay. Maybe they want to increase their knowledge on IT products and IT systems. Maybe they want to do some more stuff with integration or just be really good at starting up and checking out equipment. Okay. Recognition builds motivations. It doesn't always have to be about money, but technicians do like money. Maybe bonuses for if you, as a team, you work together to decrease energy consumption. See if you can work with the CFO or whoever does your budgets to see if we can give bonuses for the team if we reduce energy consumption. Okay. Also, shout outs are good. That helps people, just give them a shout out, give them an email or something like that with the team in front of the team. Those are always good things. People like to be congratulated on good work, so shout outs go a long way. You'd be surprised with that. Okay. Also involve them in early planning. Okay. Technicians are good for early planning, especially if they're very skilled in the software, in the network, in the existing systems. They know everything about all these different air handlers and VAV boxes in your building. So they would be very good in the early planning stages. If you're going to do a remodel, you're going to do a retrofit or something like that, or even add equipment, or even get their feelings about the current building automation system and maybe what they've seen out there. Maybe you could try a different system. Okay. So those are some ways we can empower the technicians, and that's really good stuff right there. So looking ahead, so we talked about this a little bit in the introduction about AI, and machine learning and things like that. So future success requires hybrid thinkers. When I say hybrid, that they gotta think in different ways now, because we're thinking about using different technologies, using cloud as a user interface tool now. Using maybe AI to help increase efficiency in a building. Doing machine learning in a cloud. That's a new technology too as well, to where they're getting all the information of your system, they're putting it in the cloud somewhere, and it's going to analyze potentially when we can shut things down in the future. It'll predict it in the future when we can safely shut it down. It takes weather data, maybe for the week, and maybe we can turn down the chiller a little bit earlier tomorrow because it's going to be cooler, for example. Okay. So these analytics, they need experienced humans to guide them and to verify. Just because we have machine learning capability or AI doesn't mean we just set it and forget it. We need to verify that it's actually going to work, okay? So AI is a good tool to use in machine learning, but we still need the technicians to make sure it makes sense why we're doing some of these things. And we already talked about network skills. I don't know if I want to talk about that too much more, but really it's just understanding, what the different types of subnets are, subnetting, things like that, and then how to communicate with your IT department. Okay, you got to learn how to speak their language on that. So in building systems, the jack of all trades is becoming, the standard. So you're not only going to have to know mechanical systems, you also have to know newer technologies, like we've been talking about, networking, AI, all that stuff. Mentorship is very important too. So encouraging mentorship and skill crossovers between departments is really good. Okay, so put an experienced technician with a new technician that's coming in the door, and they could be their kind of like their mentor. That's their go-to person. Anytime they have a question, they can call them and ask them. And the mentor also just kind of lays out what's important, how the building works, and how you guys operate. Skill crossovers are good between departments, like we talked about IT and HVAC. Maybe you guys can teach each other something and how that goes together. And also, as we know in our business, HVAC and especially building automation, lifelong learners will thrive. You got to be able to be accepting of continuous learning in our field. It's no longer just a static field. It's not pneumatic systems anymore, even though sometimes those are very complex too. And it's just not making schedules or making alarms like we used to. There's all kinds of stuff that we have to learn in today's time. Looking ahead, here's some things that we can talk about, and we're just going to kind of wrap up here. Let's see here. Yep. Okay, so technology is only as good as the people using it. Okay, so you can have like the coolest dashboard, like I said before, graphics. But if you don't have someone that's verifying that it's doing what it should be doing when it's doing it, then that system is kind of useless. Okay, because you can get into the set it and forget it, and it's not really doing what it's supposed to do. Now, systems don't fail because of hardware. They fail due to neglect and misunderstanding. Okay, so, but sometimes it could fail due to hardware. Of course, if a lightning strikes your controller, you could see that. But really, the systems fail because they don't understand how sequences work. They don't understand how sensors work, or maybe the effect of overriding something and never putting it back into the original the way it's supposed to run. So those are important too as well. And bridging the knowledge gap is a team effort. Okay, so from project managers or building engineers to field technicians, very important. Work as a team, educate each other as a team. If you have to get outside from your BAS vendor, call them in and have a group training session on that. Make training, communication, and documentation a culture, not a task. That's what we do at SBA here too. We help each other here. We communicate, we document good, and that's just our culture. We help each other out to get the job done, and that's just a good way to do it. Okay. All right. Well, that pretty much wraps up my podcast. So thank you very much for listening to the Smart Buildings Academy podcast. I hope you learned a lot from this episode. And if you found this episode valuable, please leave us a 5-star rating on Apple Podcast or Spotify if you're listening from those two. If you're watching this on YouTube, please like, comment, and subscribe. And as always, this episode is available on our website if you want to watch this or listen to it again. It's at podcast.smartbuildingsacademy.com, and that's /506. All right, that's all we got here. We'll see you on the next one. Take care and goodbye.